Fourth graph is the Pareto chart. It is a graph used to represent a frequency distribution for a categorical data, or nominal level, and frequencies are displayed by the heights of vertical bars, which are arranged in order from highest to lowest. Here are the steps in constructing a Pareto graph. Step 1. Arrange the data from highest to lowest according to frequency. Step 2. Draw and label the x-axis and y-axis. If you can still remember, our last topic is all about frequency distribution table. For this video we will be discussing all about the different graphs used in statistical analysis. But before that, we still start first on the discussion of the stem and leaf plot. So, basically a stem and leaf plot was developed by a statistician named John Tukey. The objective of this stem and leaf plot is to some extent overcomes the loss of actual observations brought about by the histogram. The advantage of the stem and leaf plot over the histogram is that we can see the actual observations. The stem is the leading digit or digits, and the leaf is the trailing digit. The stem is placed at the first column and leaf at the second column. We have a set of data here as an example, 50 numbers to be exact. And we need to construct its stem and leaf plot. So the stems of the leading digits for the raw data are 1, 2, 3, 4, 5, 6, and 7. While for the leaves for each stem are the trailing digit. These digits are recorded at the same row and are rank ordered to form a stem and leaf plot. Here is how the stem and leaf plot looks like. The stems are the leading digits or the tens digits, and the leaf are the trailing digits or the units digits. That's how to construct the stem and leaf plot. Let's now proceed with the construction of different statistical graphs. When the datasets contains large number of values, making conclusions from an ordered array or stem and leaf plot is often difficult. We will need graphs or charts in such situations. There are a number of graphs or charts to visually show numerical data. These include histogram, frequency polygon, and cumulative frequency. For this video we will discuss several graphical methods that are used for interval data. The most important of these graphical methods is histogram. Histogram is a powerful graphical technique used to summarize interval data, but it also helps explain an important aspect of probability. First is the histogram. It is a graph in which the classes are marked on the horizontal axis or the x-axis, and the class frequencies on the vertical axis or the y-axis. The height of the bars represents the class frequencies, and the bars are drawn adjacent to the other. Nevertheless, the histogram focuses on the frequency of each class and sacrifices whatever information was contained in the actual observations. Here are the steps in constructing a histogram. Step 1. Find the midpoints of each class. Step 2. Draw and label the x-axis and y-axis. Step 3. Represent the frequency on the y-axis and the midpoints on the x-axis. Step 4. Use the frequency to represent the height and draw the vertical bars. Again, this is how histogram looks like. Second is the frequency polygon. A frequency polygon is a graph that displays the data using points which are connected by lines. The frequencies are represented by the heights of the points at the midpoints of the classes. The vertical axis represents the frequency of the distribution, while the horizontal axis represents the midpoints of the frequency distribution. Here are the steps in constructing a frequency polygon. Step 1. Find the midpoints of each class. Step 2. Draw and label the x-axis and y-axis. Step 3. Represent the frequency on the y-axis and the midpoints on the x-axis. Step 4. Connect adjacent points with line segments. Draw a line back to the x-axis and the beginning and end of the graph. Again, this is how frequency polygon looks like. Third graph is the cumulative frequency polygon. It is a graph that displays the cumulative frequencies for the classes in a frequency distribution. The y-axis represents the CF or the cumulative frequency, while the x-axis represents the upper class boundaries. Here are the steps in constructing a frequency polygon. Step 1. Find the cumulative distribution of dataset. Step 2. Draw and label the x-axis and y-axis. Step 3. Represent the frequency on the y-axis and upper class boundaries on the x-axis. Step 4. Connect adjacent points with line segments. Again, this is how cumulative frequency polygon looks like. Fourth graph is the Pareto chart. It is a graph used to represent a frequency distribution for a categorical data, or nominal level, and frequencies are displayed by the heights of vertical bars, which are arranged in order from highest to lowest. Here are the steps in constructing a Pareto graph. Step 1. Arrange the data from highest to lowest according to frequency. Step 2. Draw and label the x-axis and y-axis. Step 3. Construct the chart by arranging the frequency from highest to lowest and from the left to right. Make a bar with the same width and draw the height corresponding to the frequencies. Again, this is how Pareto chart looks like. Fifth graph is the bar graph. It is similar to bar histogram. The bases of the rectangles are arbitrary intervals whose centers are the code. And the height of each rectangle represents the frequency of that category. Bar graph is also applicable in categorical data. Here are the steps in constructing a bar graph. Step 1. Draw and label the x and y axis. Step 2. Make a bar with the same width and draw the height corresponding to the frequencies. Again, this is how bar graph looks like. Sixth graph is the pie graph. It is a circle divided into portions that represent the relative frequencies or percentages of the data belonging to different categories. The data in a pie graph should be categorical or nominal level. Here are the steps in constructing a pie graph. Step 1. Since there are 360 degrees in a circle, the frequency of each class must be converted into a proportional part of the circle. Step 2. Each frequency must also be converted to a percentage and has a total of 100%. Step 3. Using a protractor, graph each section and write its name and appropriate percentage. Next, in the seventh graph is the time series graph. A time series graph represents data that occur over a specific period of time under observation. In addition, it shows for a trend or pattern on the increase or decrease over the period of time. Here are the steps in constructing a time series graph. Steps 1. Draw and label the x and y axis. Step 2. Plot each point according to the table. Step 3. Draw a line segment connecting adjacent points. Again, this is how time series graph looks like. 8th graph on the list is the pictograph, or sometimes called as pictogram. This suggests the nature of the data being shown. It is a combination of the attention-getting quality and the accuracy of the bar chart. Appropriate pictures arranged in a row, sometimes in a column, present the quantities for comparison. Here are the steps in constructing a pictograph. Step 1. Draw and label the x and y axis. Step 2. Draw a picture to represent a specific count of number. It must be whole number. If in case there are remaining number needed to be visualized, the picture must somehow be in half, quarter, etc. Next and last on the list is the scatter plot. This is used to examine possible relationships between two numerical variables. The two variables are plot an x-axis and y-axis. Here are the steps in constructing a scatter plot. Step 1. Draw and label the x and y-axis. Step 2. Plot the points of each ordered pairs in the Cartesian coordinate system. That's just some of the most commonly used statistical graphs. Still, there are a lot of graphs out there that is used to visualize a group of data. If you want to pursue a career into data science or even data analytics, you will learn them all across your journey. Good graphical displays tell what the data are conveying. Sadly, many graphs or charts shown in newspapers and magazines are misleading, incorrect, or complicated that must not be used. In order to correctly develop a good graphs charts, there are some guidelines that needs to bear in mind. Here are those guidelines for your convenience. Number 1. The graph or chart should include a title. Number 2. The scales for all axes should be included. Number 3. The scale on the y-axis should start at 0. Number 4. The graph or chart should not disfigure the data. Number 5. The x-axis and y-axis should be properly labeled. Number 6. The graph or chart should not contain unnecessary decorations. Last and number 7. The simplest possible graph or chart should be used for any dataset. I think that's it for now. That concludes our video tutorial for today. That is how to create different statistical graphs and how they are used in their respective different applications. I hope you learned something from this video. Our next video tutorial will be all about the measures of central tendency. If you have some questions to ask, you may comment them below. And if you also want to notice you through shout out, never hesitate to request on the comment section, my friend. I will be happy to notice you.